Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode number 53. In today's lesson, we're going to start taking a look at algorithms a little bit. So, we've looked at algorithms before. An algorithm is just a way to solve a problem. It's a list of steps to get there. We're going to do some algorithms, and we're going to do a little light timing and profiling and just to test basically just to test the algorithm and see sort of how it behaves in different situations. We're going to do it with numbers. So we're going to do sorting numbers. So we're going to do sorting algorithms. So today we're going to do the first one. We're going to talk about the algorithm, and then we're going to build up a way to work with the algorithm and test it. So let's go ahead and get started. So let's explain the algorithm first. So I'm just going to go here and open up a new, I just want a text file. And we'll call it bubble sort txt. All right. So how bubble sort works. So let's say we have a list of numbers. I don't know. We'll do Q 5, 8, 1, and 3. So there we go. So we have 5 numbers there. So for the first iteration, what you do is you take each, ignore whatever that was. You take each number and you'll start at one side and work your way across. And I've seen it both ways actually. I've seen either doing it, the largest values are going to the top, or the smallest values are going to the or bottom or left or top, however you want to do it. We're going to do top. So the order is going to be 1, 2, 3, 5, 8 is what we're going for. So the algorithm starts at the beginning. So here we'll get this. We'll get 2 and 5. And we'll check if those need to compare. And in this case, 2 is less than 5, so we're already good. So then we go to the next, 5 and 8. 5 and 8 are good. So then we move to the next pair, 8 and 1. 8 and 1 aren't good, so now we need to swap these. So the next, the first swap comes 2, 5, 5, 1, 8, 3. I need to turn Copilot off. So there's the first swap. So then we do it again, 8 and 3, and now they swap again, 2, 5, 1, 3, 8. And there, 8 is now in the proper position because it's at the end of the list. We know it can't go anymore, so it's bubbled all the way to the top. So there, to get to that point, we did 1, 2, 3 comparisons. Then we did a fourth one. So because 4 comparisons and to do 1 line. Let me make sure that's right. So compared to this one, compared to this one, compared to this one. So that's 3. Then we swapped. And then we compared to this one, 4, and then we swapped, and then we were at the end. So then next we have these numbers. So then we repeat the process, but now we don't have to consider the last position. Now we can do 2 and 5 already in the correct order. 1 and 5 are not in the correct order, so then we get 2, 1, 5, 3, 8. So there we had to do 2 comparisons. So now we do 5 and 3. Now we have 2, 1, 3, 5, 8, and they swap places, and now we're done because that was all. So here we had to do 3 comparisons. We did the 1, and we did the 2, comps, 1 swap, and we did 3 comps, 1 swap. Now we have this list. This one we actually finish up here. So what we can do here is we can do 1 and 2. They are invalid. So we go from 1, 3, 5, 8, and then we'll do 1, 2, 3, 5, 8. So there we did one comparison and one swap. And finally, we still have to check 2 and 3. 2 and 3, no swap, and we're done with that line. Then we check the last two positions. So there's one more comparison. The no swap, and then we do one final comparison. So this is not the most efficient algorithm for sorting, but it is relatively intuitive. You're just bubbling up. So we're going to implement this basically, and this isn't the greatest example. I might try to do a better example, or you can probably find a good visualization online. That would probably be you can find another one here on YouTube, I'm sure. That's what we're going to implement. So let's begin. So I've got a workspace here. Let's do this. Convert names, or convert that. All right. Let's begin. So let's do a class. We'll move this to its own file in a minute. I could do this as just a method if we would rather. So we might should, just for testing purposes, actually. Let's do it as a method inside the other class. Static int. I was trying to think how I want to do it. Let's do it like this. We'll do it void bubble sort int numbers. We will do it like that. So what we're going to do is we're going to sort the array, but we're not going to return the array. We're just going to use the fact that it's a reference to an array. So other ways you could do that, I think this is how I want to do it though. So let's go with this route first. So let's begin. So the way I see to do this is 2 for loops. So let's give that a try. So first thing first, if numbers.empty count equals 0, return. So if it counts 0, there's nothing there. It's length because we're array though. All right, so just to begin, we'll do that to make sure there's no, not empty. So yeah, I believe that's actually probably what we're going for. So let's just begin there and let's see what turn off. Let me turn this off. Yeah, let's turn this off just because it's going to keep spoiling it for us. I think it's that one. Yeah, I believe it's that one. So let's see. Okay, yeah. All right, so let's begin. So bubble sort. So we'll say for int I equals 0, I less than. So I'm thinking of the length, but I don't think I want it to be the length. So what we wanted to do is we wanted to sort of only go to the end. Let's do an end counter. Let's try this. I'm not sure if this is how I want to do it, but we'll try it first. Equals that. So we'll try that, and if we need to adjust it, we will. Int j equals 0. Wait a minute. We want I to be 1. I minus 1. J less than. Wait a minute. I'm already messing it up. So I'm going to say I is the first counter, J is the next. So we'll check that, check the next one, and then we'll move the pairs together. Let's do it like that. So I'll say I and j compare, I and j compare, and let's do it like that. So let's forget about the for loop, and we'll just do it as while. So we'll do int ij. So let's do it like that. So while end is greater than 2. Reason greater than 2 is at the end there's just going to be 2 values here. When the end drops less than, while end is greater than or equal to 2, then wait a second. All right, sorry, we're back. And so what I was trying to do is do a counting method. I think what I actually want to do is not that. So let's see, where were we? End equals the length. That still makes sense to me, but yeah, let's do this. Let's do full is sorted equals false. Let's do it like that. That way we'll say if it's not, if it's sorted, we'll use that as our counter instead. So for var int I equals 0, I less than numbers.length I plus plus. Yeah, let's just get it working first, and we'll fix it afterwards. Why is that not going over? There we go. So for int j equals 0, j 1, j less than numbers.length. Nope. Here is sorted, so let's make it better later. We'll come back to this sorted. So let's just go through. So now we have a pair, so I and j. So if numbers at I is greater than the numbers at j. So that's if I is bigger, then we'll swap. So swap. So we'll do swap as another method. So we'll do public static void swap. And swap takes int. We'll do that. Well, let's use I and j since that's what we're using, and we'll pass in the array. So 2 ways to do a swap that are 2 common ways. So the first one here, let's just demonstrate it. So this is the traditional way. You'll get a temporary variable, numbers at I, just like that, and numbers at I gets numbers at j, and then j gets temp. That's the traditional swap. So you just get the first value, swap the second, get the third, and then you're done. And that works perfectly fine, and that's what you'll see in many languages, and I'd say that's still probably a common one. You can actually do it through C# through tuples. You can do this. You can say nums at I equal nums at I, nums at j equals nums at j, nums at I. And that should do the same thing. We'll test it and make sure, but I think that should work fine. In fact, let's just test it just to make sure. So let's do it int equals that. Just do that, and let's just swap the first positions. So swap 1, 0, 1, and array. Now we'll want a method to print the array, so let's just do that. Static void print array. There we go. So I just want string.join there we go, and now we'll print. All right, so let's see what that does. So does that give us 2, 1, 3, 4, 5? And it does. That's called deconstruction, and that's one way to do a swap method. Let's move that down there. We'll have a utility section down here. All right. Back here though. All right, so now we need to swap I, j, numbers. We don't technically care what order here. The swap's just going to swap the two positions, so that should be all we need. So once this finishes, we should have a sorted array. So I think that should be all. So let's test it. We'll use that same numbers we used a minute ago. These. Let's see what happens. See where I made a mistake. And we'll make this a better test here in a minute, but we'll test this first. All right, so we'll print the array before and after. So let's see what this does. Yep, definitely busted. So let's figure out what happened. All right, so first we start at the beginning, so 0 and 1. So first we check these two. I is not greater than, so they stay the same. Then next time we go through, we do this one. I is still the same. Then we do this one. Now they should swap. I wish I'd kept the terminal open, but I closed it. And then they'll swap. Tell you what, let's do this. Let's add a console.writeline here. Let's do comp. Let's just say numbers at I. I want that as the variable though. Greater than numbers at j. We'll test it like that. So what that'll give us is we'll be able to see what it does at each comparison. We'll do one here too. Swap I and j, something like that. So that'll give us a little log of what happened. So we do a compare, not greater than. Okay, I see what my mistake is. So this is the this one I'm searching through 2 and then comparing it, and 2 and comparing it, 2 and comparing it until I find one that 2 is greater than. So that's exactly the condition here that's wrong. I don't want it to be the other way around. I want j to be greater than. So that condition's wrong. So there's another problem there though. So as we're going through it, what we're doing is we're doing 1, 2, or I, J, 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 and then I, J, 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 like that. So instead of that, what we would want to do instead is for I and J to go in sync. So to do that, I would be tempted to do the while loop, like I said before, but we can do. I think we can still do this. So we start here at the beginning. Yeah, let's just drop the inner loop. So we'll say int j equals I plus 1 if j is greater than numbers dot int minus 1. Continue. And now I want my other one of those. Let's see. So pull this out. All right. So here's our second attempt. So when we see this, we're going to see that this isn't going to work as well, but let's run it anyway. Now we've got a little closer, but now still doesn't look sorted at all. So what happened here? In this case, we checked 2 and 5. And my numbers are still wrong. Wait a minute. I had it right the first time. If this one's greater than. I should have went with my first instincts. So let's try it again. This time, still nothing. Now we got the 8th at the top though. So what happened there? So it ran one cycle. So if we look at this, this should look similar to our bubble sort here. So this should look a little bit like this. If we look, there is 1, 2, 3, 4 comparisons and 1 swap. So suddenly that looks sort of like what we intended. So now this is where I'm going to put the is sorted. So now we're going to do bool is sorted equals false. Now let's wrap this in a while loop. Let's see if we can do this. Let's see, if I right click here, do we get a snippets? Do. I'm going to go to a snippet. So snippet's just a way to put something around, like we can add it and it's already set up for this. So we can do while is sorted, and while it is not sorted. So here, false. And let's swap the order. Let's say while is not sorted. Now we'll say true. And how do we tell if something is not sorted? So we actually want this to be false. And now we'll set it false here at the front. However, anytime we do a swap, then suddenly it's not sorted. So now if we run this, getting closer. So what happened there? So that time we just hit this twice and it never went inside. Which is wrong because it should have went inside. So what happened there? Oh, that's even these prints, so it didn't even get in there. So we'll assume for the first time it is true. Okay, I had it right the first time. And then we'll say, okay, it's not sorted, and then we'll test that hypothesis. There looks sort of sorted, and let's see how that compares with their bubble sort text. There we have four sorts, and then an attempt. So there, Here we swap. Here's 3. Here, let's make that easier. Let's match it just a little more. Let's do a print inside of here. At the end of each loop, we'll do a print numbers. So make it a little more matching to what we have over here. Still won't be exact, but there. Now here at the end of the first cycle, we have 2, 5, 1, 3, 8. We had 4 and 2 swaps. We have 2 swaps? Well, we did have 2 swaps. I didn't count right. So what happened there was we swapped these 2 and then we swapped these 2. So I had a wrong count. Next, we go through, we do a swap. We come out with 2, 5. Oh, wait a minute, that's where we're at. Now, here. So we do 2 compares, then we swap, then we compare, then we swap, then we compare. So it makes sense, but we're missing a compare here. Then we get 2, 1, 3, 5, 8. Good. Compare. Swap the first 2. No more compares. 1, 3, 5. So there we are sorted. Like I said, we then go through and make sure we don't have anything else. We don't. We print it and we're done. Okay. So there's a very rough, very together bubble sort. Let's remove our console logs for a minute. I'm going to do Control K, Control C because I might want these in just a second. We have another one. Oh, this. All right, so there's just a little attempt. Let's do a little better. Right now we're using length. Let's do our end. I was trying to start with. Do it like this, and now let's see, one more thing. Now it's decrement end at the end of this. So now let's see if we still get a sorted list at the end. Doesn't look like we broke it. Now if we undo these, this is why I wanted to keep them in, was just so we can see this. So before we had, I think we should see fewer sorts happening. Yeah, the list is a little shorter. What's happening is we're cutting down the list each time. So each time we go through the list, here it's 5 characters, here it's only 4 we're concerned with, here it's only 3, and then the last one it's only 2. In doing so, we made ourselves a little more efficient. So that's one thing we can do. What we can do in here now, though, let's do this. Let's do Control K, Control C here. Let's disable this, and disable this. So let's do some optimization, or let's do some profiling. So checking how we can see how this behaves. Actually, let's do one more thing. Let's do profiling, or let's do some analysis first. So here we're running on a list of numbers. So let's do that big O notation we did before. O of what are we? It's going to be in something because we've got a list of numbers, so we're going to have to go through the numbers. So let's see what we get. So here's one comparison. So one operation. Here's an operation. Here's an operation. And this is just rough. I'm not going to go into detail. There's actually 2 operations here, but I'm not going to go into that detail. 3, 4, 5, 6, 7, 8, 9, 10, 11-ish, and 12. So 12 total, but there's a suspicion here. This happens multiple times, so while it's not sorted. And in this case, at worst case, we're going to go through it at least n times, because it's technically going to be n minus 1, but if we remember right, the n doesn't actually, or the -1 doesn't matter in that case. So we have to go through at least, however big the number is, -1 each time. So what we're going to find there is we get n for this loop. This one is O of n. However, it's got an inner one, and this inner one does the same thing. So we have to go through the list, at worst case, at least through the entire list once. So big O of n as well. The rest of these are just sort of trivial. So big O of n. So there's 2 of them though, so it's n squared because we have to go through this one n times. So n times n plus some numbers. So I don't know what, I think it's a 15 maybe, 15-ish. The 15 doesn't matter, and we get big O of n squared. So that's the worst case. It's also the average case. The best, or we can actually do, in best case, it's actually a little better though. Worst and worst case to average case. So average case is the same because we have to go through the same workflow. Big O of n squared. So worst case, big O of n. So why would it be big O of n? So let's do a worst case without early ending. Then it becomes big O of n squared. So without the early end here, like if we don't do this decrement, without that case, it's big O of n squared. If we duplicate that line, big O with early ending, then we get n. Because at that point, then we shrink the list each time. So at worst, all right, wait a minute. This case. Oh yeah, yes. So with early ending, this works. So the best case for bubble sort is it's already sorted. So we just go through the list once, it's already sorted, and we're done. Let's see. So these are time complexity. Let's look at space as well. And it is big O of constant. So it's constant because we declare some variables. What I just did. We declare some variables, and but that's really all we do. We declare variables. We manipulate the array. We manipulate the array. We manipulate an array. We don't actually declare a new array, so we're not really taking a lot much more memory. It's just we do use a little bit, but it's always constant. We always use the same amount of memory. So it is big O of 1 constant time. Think of anything else. There's a concept. I want to say it's stability. I should have looked that up. I think basically it's a stable sort. So the idea is, so if you have elements with the same value, like if you have 2 2s in here, they'll end up in the same order. For numbers, that's probably not all that relevant, but this case should work. If we run it here, we should get to 2s in order. And in fact, it's this 2 matches this 2, this 2 matches this 2. That's called a stable sort. It's basically stable. It happens in the same order. Let's add a flag here. So bool in early equals false. Let's do it like that. if end early. So that adds us a little more complexity here, but it speeds it up, but it gives us a way to control that speed up. All right, here we go. Here's just a bubble sort. Let's do some profiling on this. So the correct way to do this in .NET is use benchmark.net. It's a separate library NuGet package you can pull in, and it lets you do all kinds of fancy number counting. You can see how much memory you take, how you can see the relative runtimes. You can use that to gather metrics, and it'll run it multiple times, run it more effectively than what we're going to do. We're just going to use a built-in one. Let's do stopwatch. The stopwatch is going to need to using up here, using system.diagnostics. And here we can do u equals new. All right. So there. Here I'm going to do sw.start and sw.stop. Now print array. Let's do I guess let's do total milliseconds maybe. That's not going to be interesting for one this small. Let's do CW. So stopwatch will have some properties. So let's do time to run. We'll do SW dot. I guess let's do elapsed dot total. Maybe microseconds. Let's see what they look like. $170. That might be all right. Let's do nanoseconds. So if you have an older version of .NET, you won't be able to do nanoseconds, total nanoseconds. It won't be an option. But there, let's do it like this. Let's do that, but let's do I don't know how to customize it with a comma. Let me Google that real quick. Let's see, it may not even be easy to do. Okay, it's just an N. Let's see if that works. Yeah, there we go. Okay. And we can drop the points, so we'll just do N0. Yeah, there we go. All right, so I think that's reasonable. So what this is saying is it's running in that many nanoseconds, and if you notice, each time I run it, it's slightly different. So let's do this. We'll do for var I equals 0, I less than 10, I plus. So we'll do a little warm up here. So here, and we will need to print this each time. Here, and we can remove it. Now let's keep that one. We'll remove that one. Now let's see what happens for 10 runs. There, it took a really long time the first time, and after it was warmed up, then there wasn't a whole lot of anything after that. In fact, running in even sets of nanoseconds looks a little suspicious. So let's see. That's just for 5 values. So let's bump it up. Let's do something bigger. What was my original number? Do 5. So let's do a way to customize the our input array here. Yeah, let's do way to customize this. So we'll take in a number, CW, enter number of elements to test with. Less than 1 billion. I don't want to deal with not using integers for this. In fact, we might be able to limit the array to actually thinking about it. We'll do string number of elements. And we'll just say console.readline or 10. So we'll say 10 is the default. Yeah, so let's see. So now let's generate this. So we'll have let's do a method here. Generate array, passing in number of elements. Let's create this method, generate the method. So here we'll do I'm doing that as string. Let's cast that here. We're gonna assume the user. I'm not writing this as a good program. I'm writing it for me, so I'm gonna assume I know how to type a number. So it will crash if we don't. So keep that in mind. So let's do this. Let's do int dot try parse number of elements value. So if this is invalid, or -1. Now let's pass in value. Int value. Not valid. I guess just return. There we go. So let's generate an array now. So now we're going to need a random number. So we'll have to include random. So random. I guess we don't need this. So let's see. So that will return R at the end. So let's populate this. So 4 var I equals. Let's do it like this. Let's have this full allowed duplicates equals false. So if allow duplicates. So for allow duplicates, it's easy. So we'll just do 4 for I equals 0, I less than number of elements. All right, I equals that. Next, not next int, yeah, next. There we go. So there's just random values. And they're positive, so that's good. So we'll do positive only for now. We might have a bool allow negative. Allow negative values. But we'll set it to false for now. We might do that as a next step. Here we'll set it here. So there's us if we allow duplicates. If we don't allow duplicates, here we want to be a little more careful. While var count equals 0. So while count is less than number of elements, then var random equals var.next. Now, if our dot contains random continue, else our count equals random. Count plus plus. So we can do count plus plus on the inside here. This is valid code as well. Whichever way you prefer. I probably actually prefer it separate, but I'll leave it like that. So there. So now what we did there, so we take the count, while the count's less than the number of elements, then we get a random number, we check if it's already there, if it's a duplicate, and if it's not a duplicate, we add it to the array. And this is one line, so we'll do it like this. There we go. Alright, so there's this very simple generate array method. So we'll assume 10's the default. Yeah, we'll assume 10's the default. Okay. So let's do this. So now yeah, okay. So we'll do the default, so we'll do 10. There, you see it's all over the place, but it's relatively fast. There, the numbers. A little hard to tell if they're actually sorted. They are, but it looks like it's a little hard to tell with that big a number. So, tell you what, let's do this. Let's go here. Make a function to actually check array. Let's say that. Check array. Check is sorted. Let's just say it's sorted. Array. We'll do it like that. So far, full it's sorted equals it's sorted. We'll do it like this. So we'll say is array is sorted. It's sorted. There will just give us a little method here to actually just check if it's sorted, so we're not going to print it out, because when we do a lot more methods, we're not going to want to read through them anyway. But here, we'll just loop through it for each var in an array. And previous equals array at 0. And now we need to use a for actually. For var I equals 1, I less than that, I was plus. So if array I is greater than or equal to previous, continue, else return false, return true. So there we go. There's this little method to check if we were successful. And we could probably throw an exception there just to make it stand out, but I think this will do. Now if we run it, we'll do 10. There we go. And everything's all jumping around. It's hard to see because 10's still not that many variables. Let's bump that number up. Let's go to 100. Still discounting the first one. The first one has warm-up time, like I said, so discounting it. In fact, we could probably just drop the first one. Make that 11, and we'll drop the first one. We'll probably want to make that configurable. If I equals 0, consider making that configurable. So there, now we'll drop the first one so we won't even see the warm-up element. So 1,000. Or did not run. If it does not equal 0. 1,000. Being a little more consistent. So now, when we do 100 or 10, little fluctuations there are just happening because of everything else going on. When we jump up to 100, it's still the same thing basically. We're not seeing a lot of difference. And now everything's a little closer together. The numbers are making a little more difference. 1,000. All those look a whole lot more or closer together. They're within, what, 200 nanoseconds of each other, 300 nanoseconds of each other. Do 10,000. We'll probably start seeing it take a little bit. There we go. There's an outlier, but everything else looks like about within a couple hundred nanoseconds of each other. What's happening with that? So what could be happening there would be maybe the ignoring this, but maybe the number of elements now is starting to make a really big difference. Do it again with 100,000. Now, notice it's so slow, we're not actually going to be able to see it finish, actually. I think... yeah, it's going to be too slow to finish, but... what we should be seeing is that as we increase it 10 times, the time was taking 10 times as long. And yeah, this one's going to take a little while to finish. So what we could do is we could plot that out in some graphing utility, and we could see the trend. And what you're going to see is that there we go. You notice that number is about 10 times as big as 100,000 was, and 1,000,000 will be about 10 times that. So whatever puts them in the millisecond range, I guess. Let's check this. Let's do yeah, it was the first one that took so long there. Yeah, so there's just a little light one, and we'll need to actually play around with the bubble sort next time. So you're actually out of time for this one. So let's do this. Let's do we'll add a to do here. To do check early ending and see if we can optimize. What else? There was something else I'd noticed. What was it? To do control duplicates and negative values. So negative values some stuff could pose interesting problems. For our situation, it doesn't really. For the bubble sort here, it's going to work because of how integers work in C#. It should be fine. I don't think I foresee any problems. We may try that next time. But we'll have to adjust the generate array here to adjust duplicates, which we did, but to allow negative values as well. That seems like a good next steps. And then we will actually run through and actually do try to graph out the values a little bit. Maybe, I guess maybe use Excel or Google Sheets or something and graph out the values a little bit. But that'll be where we pick up next time. So we'll go ahead and call it here. Save. Figure out which one's actually saving the new world. This one. So same icon. Good. All right. Yeah, we'll call it there. So this has been Programming with Shadow, episode number 35. Not 35. 53. Completely flipped. 53. All right. Thanks for watching. Have a good rest of your day.